Today we're looking at the Reteach 8-2. Again, this Reteach page is for your notes. All those reteaches are always part of your notes. We're looking at the trigonometric ratios. The ones we look at are our sine, cosine, and tangent. So if I have a right triangle, any right triangle, because I've got a 90-degree angle, if I know one of the other angles, I can find the ratio of the sides, the ratio of the side to a hypotenuse, the ratio of the sides to each other, and those different ratios are called sine, cosine, and tangent. I remember the which one goes with which by remembering the math battle cry of SOH, CAH, TOA. That SOHCAHTOA battle cry helped me remember that the sine of my angle is the opposite side over the hypotenuse. So if I'm looking at the definition they're giving me, the sine of angle A, the leg opposite angle A over the hypotenuse. If I look at angle A, the opposite side is 4, the hypotenuse is 5. Gives me my fraction 4/5, which is 0.8. That SOHCAHTOA, the CAH, C-A-H, reminds me that the cosine of my angle is equal to the leg adjacent over the hypotenuse. So if I'm looking at the cosine of angle A, the adjacent side is 3, the hypotenuse is 5, and I get that ratio 3/5, or 0.6. And if I'm looking at my SOHCAHTOA, that TOA part of it reminds me that the tangent of my angle is equal to the opposite over the adjacent. So the tangent of angle A is the opposite 4 over the adjacent 3. Gives me that fraction 4/3, which is about 1.33. Remember, we've been looking at our special right triangles. We've been looking at our 45-45 90-degree right triangle. And if I were looking at finding the trig ratios that involved there, if I were looking at the sine of 45 degrees, I'm looking at the sine of angle Q. I want the opposite side over the hypotenuse, which gives me x over x square root 2. The x's cancel out. I'm left with 1 over square root 2. Or, if I'm rationalizing that denominator by multiplying the top and bottom of that fraction by square root 2, I get square root 2 over 2. So the sine of 45 is a square root 2 over 2. We're going to be looking at both of these right triangles in a couple of the examples on this page. If I'm looking at the first 4 problems with this right triangle with legs of length 8 and 15 and my hypotenuse of 17, again, I want to figure out the trig ratios, and I need to remember that SOHCAHTOA, so I'm going to write it again here. If I'm looking for the sine of angle K, I know that's going to be the opposite side over the hypotenuse. That's that SO part. So I look at angle K. The side opposite is my 15. My hypotenuse is 17. And I've got my ratio written as a fraction. If I wanted to figure out what that is, a decimal value, I just go ahead and put that in my calculator. To get 0.88. If I want the cosine of angle H, that CAH, cosine means adjacent over hypotenuse. So if looking at angle H, my adjacent side is 15, my hypotenuse is 17. And that's going to give me my same decimal value of 0.88. If I want the cosine of angle K, again, CAH, that adjacent over hypotenuse, I look at angle K. I want the adjacent side 8 over the hypotenuse 17. And to get a decimal value for that, I get 0.47. If I want the tangent of angle H, that's that TOA, opposite over adjacent. I'm looking at angle H. The opposite side is 8. the adjacent side is 15. And to get a decimal approximation for that, gives me 0.53. So I'm just using my SOHCAHTOA to figure out what's going on with my problems. I'm going to be referring back to these two special right triangles to answer the questions 5, 6, 7, and 8. So if I'm looking at my 45, 45, 90 triangle, and I want the cosine of the 45-degree angle, that's that ka. That means I want the adjacent side over the hypotenuse. So I'm going to go back and look at that 45, 45, 90 triangle. My 45, 45, 90 triangle. I want the adjacent side, which is 45, which is my length x, over my hypotenuse of x square root 2. Notice that this is exactly like the example problem that we looked at, where we took the sine of 45 degrees, x over x square root 2, and our final answer, we ended up with the square root of 2 over 2. If I'm looking at the tangent of a 45-degree angle, tangent, that's that TOA, opposite over adjacent. For a 45-degree angle, the opposite side is x, the adjacent side is x, x over x. Any number divided by itself reduces to the whole number 1. If I'm looking at question number 7, I want the sine of 60 degrees. Remember that's SO, opposite over hypotenuse. I'm looking at my 60-degree angle. My opposite side is x square root 3. My hypotenuse is 2x. So I have x square root 3 over 2 times x. Notice that the x's will cancel out. And I'm left with the square root of 3 over 2. The last question on this side of the page, where I'm looking at the tangent of the 30-degree angle. Again, I'm looking up at my 30, 60, 90 triangle. The tangent function I know is TOA, the opposite over the adjacent. If I'm looking at my 30-degree angle, my opposite side is x, my adjacent side is x square root 3. So my opposite over adjacent becomes x over x square root 3. My x's cancel out. I'm left with 1 over the square root of 3. But I don't like to have a radical sign in my denominator, so I'm going to rationalize the denominator by multiplying top and bottom of my fraction by square root of 3. That gives me a final answer of the square root of 3 for my numerator and the whole number 3 in my denominator. So the square root of 3 over 3 is the answer to what is the tangent of 30 degrees. On the back side of the reteach, we're actually taking a look at some of these trig ratios. Please make sure that you set the mode of your calculator in degrees, because you can't take the cosine of 38 degrees without having the mode in degrees. So in your calculator, in order to do that, I need to go to that second mode function. Sorry, I wanted to go to the mode function. In my mode, I've got third one down is radians or degrees. Anytime you pick up a calculator, if it's been reset, it's going to be in radians. I need to scroll down, highlight the degrees, hit enter so that now degrees is highlighted. Second mode comes back and quits me to my home screen of my calculator. And if I want to type in the cosine of 38 degrees, Again, my trig functions are in the middle black row here, my sine, cosine, tangent. So my cosine of 38 degrees gives me the decimal number that you see here. Usually we round to the nearest hundredth, so 0.788 rounds to 0.79. We also use trig ratios to find the lengths of different sides of triangles, and we have to set up that equation first. Once I set up an equation first, if I'm looking at this triangle, I'm looking to find the length of WY. I have 39 degrees. This is my side that's opposite, or actually I'm looking for WY, I'm looking for my hypotenuse. That's where my X is going to go. I have my adjacent side. I know that means I'm going to use my cosine function because of that. So ka toa. I know the cosine equals the adjacent over the hypotenuse. So my adjacent side is 7.5. My hypotenuse is what I'm looking for. I always set up this equation first because if I don't set up the equation, I'm not going to know whether I'm going to multiply or divide to solve for that. When I have this problem and I need to cross multiply to solve for it, I'm going to end up with 7.5 divided by the cosine of 39, and that's going to give me my approximate answer. The first couple of questions, we're just putting these in our calculators. So if your mode is in degrees, then you're ready to just do some number crunching. If I want to find the sine of 42 degrees, I'm just going to take my sine 42, hit enter, and get 0.669. I'm rounding to the nearest hundredth, so that's going to be about 0.67. If I want the cosine of 89 degrees, I just hit my cosine, 89, 0.017, which is close to 0.02. Tangent of 55 degrees, just punching my tangent button, and I get a 1.43 as my estimate. Remember, tangent's the only one that can give us an answer bigger than a whole number 1. The sine of 6 degrees gives me pretty much a 0.10. So that's just a number crunching exercise. We're going to take a look at the last 4 problems in a separate video just because I'm running out of time on this one.